all of you are doing good. Let's start today's chapter, Algebraic Expressions. Introduction. In the previous class, we have learned about the addition and subtraction of algebraic expressions. In this chapter, we shall study the multiplication of algebraic expressions in the form of monomials, binomials, etc. and their applications in solving problems. We shall also learn how to factorize algebraic expressions. Now, let us briefly review some of the concepts and definition. We have two kinds of symbols, constants and variables. A constant is a symbol having a fixed numerical value. A symbol having no fixed numerical value and which can take various numerical values is called a variable. Example, we express the parameter of a rectangle as p is equals to 2 in bracket length plus breadth. Here p, l and b are variables while 2 is a constant. Next is algebraic expressions. A number of combination of numbers, constant and variables connected by the signs of fundamental operations of addition, subtraction, multiplication and division is called an algebraic expression. The different parts of an algebraic expression which are separated by the sign plus or negative are called the terms of the expression. Example, 4x square minus 4xy plus 5y square is an algebraic expression consisting of three terms. So that is 4x square minus 4xy and 5y square. Okay. Number 2, this is an algebraic expression consisting of 4 terms, that is 2x square, 6x minus 4y and 8. Monomial, an algebraic expression having only one term is called a monomial. For example, all these expressions are monomials. Binomials, an algebraic expression containing 2 terms is called a binomial. For example, these expressions, these are binomials. Trinomial, an algebraic expression containing 3 terms is called a trinomial. Thus, expressions like these are trinomials. And factors. When 2 or more numbers, constant and variables, are multiplied, then each one of them and their product is known as the factors of the product. A constant factor is known as numerical factor, while a variable factor is known as a literal factor. In a product of numbers and variables, any of the factors is called the coefficient of the product of other factors. Okay. For example, in x, y, z, 16xy, z, right? 16xy is the coefficient of z, okay? And 16xz is the coefficient of y. Similarly, 16yz is the coefficient of what? X, right? 2. In minus 10x, minus 10 is a coefficient of x and minus x is the coefficient of 10. 3. In 3xy, 3y is the coefficient of x and 3x is the coefficient of y. Constant term. An algebraic expression having no literal factor is known as a constant term. Thus, in the expression, the constant term is what? Minus 8. Like term. Terms having same literal factors but with different numerical coefficients are called like terms. Unlike terms. Terms having different literal factors or different degree of literal factors are known as unlike terms. For example, in the expression, as you can see here clearly, x square and minus 4x square are like terms, while minus 2xy and y square are unlike terms, means not same. Degree of a polynomial. The degree of a polynomial of one variable is the highest power of the variable. If the polynomial has more than one variable and every term has its own degree, then the degree of a term is the sum of the powers of its variables and the highest degree so obtained is the degree of the polynomial. For example, in this expression, as you can see, the degree of the expression is 4 as it is the highest power in all the terms of the polynomial. Okay. Next, addition and subtraction of algebraic expression. To add algebraic expressions, we collect and add like terms. The sum of several like terms is another like term whose coefficient is the sum of the coefficients of those like terms. We cannot add the coefficients of unlike terms. In order to subtract an algebraic expression from another, we change the sign from positive to negative or from negative to positive, as the case may be, of all the terms of the expression which is to be subtracted, and then the two expressions are added. The following examples will illustrate the procedure. So, we have to add these expressions, okay. So, expressions are 3x square minus 5x plus 7 plus minus 8x square plus 4x minus 3 plus 11x square plus 7x plus 8. Now open the bracket. 3x square minus 5x plus 7 minus 8x square, because there is a positive sign before the brackets, so we will not change the sign, plus 4x minus 3 plus 11x square plus 7x plus 8. Now we will combine the like terms. 3x square minus 8x square plus 11x square minus 5x plus 4x plus 7x, then plus 7 minus 3 plus 8. Okay. 8 minus 3 is minus 5x square plus 11. So 8 minus 6, 8 minus 5 is 6, 6x square. 7 plus 4, 11, 11 minus 5 is 6. Plus 7 minus 3 is 4, 4 plus 8 is 12. So this is the answer, 6x square plus 6x plus 12. Okay. Exercise 12.1. Classify the following into monomial, binomial and trinomial. Okay. There are 2 terms, so binomial, only 1 term, monomial. Okay. 3 term, then trinomials. Okay. Multiplication of algebraic expression. While multiplying algebraic expressions, we shall be using the following rules of sign. Number 1, the product of 2 factors with like signs is positive and the product of 2 factors with unlike signs is negative. So thus we have plus into plus is plus, plus into minus is minus, minus into plus is minus, and minus into minus is plus. Number 2, if a is any variable and m and n are positive integers, then a raised to the power m into a raised to the power n is equals to a raised to the power m plus n. Okay. And if a raised to the power 3 into a raised to the power 6 is equals to a raised to the power 3 plus 6, that is a raised to the power 9. Okay. Now multiplication of 2 monomials. Multiplication of one monomial with another monomial is the simplest form of multiplication. The coefficient of the product of 2 monomials is equal to the product of their coefficients, and the variable parts in the product is equal to the product of the variables in the given monomials. Okay. For example, we have to multiply 2x square y cube and 7xy square. Okay. So what will you do? You will multiply 2 by 7. 2 into 7 is 14, x square, and there is a 1 power of x. So 2 plus 1 is 3 and y, 3 plus 2 is 5. Okay. So 14 x cube y raised to the power 5. This is the answer. Okay. Next, multiplication of a monomial and a binomial. To multiply a binomial by a monomial, the distributive property of multiplication over addition is handy for us. We know that if p, q and r are 3 monomials, if p into q plus r is equals to p into q plus p into r, and p into q minus r is equals to p into q minus p into r. Example, we have to multiply 5x minus 2 by 3xy square by 1 by 7 xy. Okay. So first you will multiply by this 5x into 1 by 7 xy, then minus 2 by 3 xy square into 1 by 7 xy. Okay. 5x square y by 7 minus 2x square y cube by 21. Okay. So this is also known as a horizontal method, and this is the column method. Through this method we can also calculate this. Okay. Let's do exercise 12.2. Find the product. 2x square into 9x square. 2 into 9 is 18. X is 2 plus 2, x raised to the power 4. Okay. Multiplication of 2 binomials. To multiply a binomial by another binomial, we can conveniently use the distributive property of multiplication of literals over addition. It is explained below. Let there be 2 binomials, say a plus b and c plus d, using the distributive property of multiplication of literals over the addition. We have this identity. Okay. Now we shall consider some illustrative examples. Example 1 is we have to multiply 4x plus 5y by 2x plus 7y. So, what will you do? First, you will multiply this by 4x, that is 4x multiply 2x plus 7y plus 5y, and then multiply this 2y plus 7y. 4 into 2 is 8, 1 plus 1 x square. 4 into 7 is 28 xy plus 5 2s are 10, this is x, 10 xy plus 5 into 7 is 35y square. So, 8x square, these are like terms, so we will add them up, 38xy plus 35y square. Okay. Multiplication of a binomial and a trinomial. Now, the distributive property of multiplication over addition of literals can be extended to trinomials and to all algebraic expressions containing any number of terms. The following examples illustrate this. Okay, so we have to multiply this by this. So, we will use this column method. First, we will multiply by 7. 7 2s are 14 x cube. Okay, 7 2s are 14 x cube, then minus 7 4s are 28x square plus 7 2s are 14x. Then we will multiply by minus 3. Okay. So, minus 3 into 2. 3 into 2 is 6x cube plus, because why plus? Because minus 3 into minus 4, minus into minus is plus. Okay. So, 12x and then minus 6. Then we will add or subtract accordingly. Right. Let us do exercise 12.3. Multiply the following. Okay. So, you have to multiply 2x plus 4 by 6x plus 5. So, you write 2x, 6x plus 5 plus 4, 6x plus 5. 2 6s are 12 x square plus 5 2s are 10x plus 4 6s are 24x plus 4 5s are 20. 12x square plus 34x plus 20. So, this is the answer. Okay. Things to remember. Number 1, the product of two monomials is the product of their coefficients and the literals in the two monomial, the exponent of each literal being the sum of its exponent in the given monomials. 2, to multiply a monomial by a binomial, we multiply the monomial with each term of the binomial and add the products. 3, to multiply two binomials, we multiply each term of one binomial with each term of the other and add the products. 4, to multiply a binomial and a trinomial, we multiply each term of the binomial with each term of the trinomial and add the products. So, students, here comes the end of this chapter. Now, keep doing practice of the remaining exercise.